आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
Hello everyone, let's start this question. Now in this question we have to define the following terms. We are given with the first is mole fraction. Now what is mole fraction? Now this is the concentration terms which tells us about the concentration of the solution. This is the one of the concentration terms. We have another concentration terms as molarity, and like that we have mole fraction. Now what is mole fraction? This is represented by the symbol chi, and we measure the mole fraction of solute or solvent. Now if we write the mole fraction of solute, basically it is the ratio of number of moles of solute to the total number of moles in the solution. We can write this total number of moles as number of moles of solute plus number of moles of solvent. Similarly, if we write this concentration terms on the basis of solvent, then we write mole fraction of solvent, that is chi solvent is the ratio of number of moles of solvent to the ratio of number of moles of the total present in the solution, that is N solute plus N solvent. N solute plus N solvent. Now basically this is the ratio of number of moles. Now one more thing, if we add up these both ratios, we get that mole fraction of solute plus mole fraction of solvent. It can be written as N solute divided by N solute plus N solvent plus mole fraction of solvent, that is N solvent divided by N solute plus N solvent. Now if we add this equation, we get that denominators are same, so we can directly add them, N solute plus N solvent, and in the denominator as well we will get the N solute by N solvent, and this will get cancelled because the numerator and denominator are same, so which means that the mole fraction of a solution combined is 1. So this is the term mole fraction. It is a unitless quantity because it is a ratio, so it is also a unitless quantity. Unitless. Now we have second term, that is isotonic solutions. Now we have isotonic solutions. Now this isotonic solution basically is dependent on the one colligative property, that is osmotic pressure. Osmotic pressure, that is written as pi. The symbol is pi. Now this is one of the colligative properties. Colligative properties are the properties that are dependent on the number of moles. So this is the colligative property, and isotonic solution is in the reference of the osmotic pressure. The solutions that have equal osmotic pressure, suppose we have solution number 1 with osmotic pressure as pi 1 and solution number 2 as osmotic pressure as pi 2. If pi 1 is equals to pi 2, then we can say that the solution is isotonic. Now one example is 0.9% weight by volume of NaCl, aqueous NaCl, is isotonic with blood. It means that they have the same osmotic pressure. Now this is the example. So this is the isotonic solution. Now we will come to the third concentration term, that is the want-Hoff factor. We have third term as want-Hoff factor. Now what is this factor? Now we discussed that the colligative properties are the properties that are dependent on the number of moles. Now we know that in a solution, if a solution undergoes dissociation or association, this will impact the number of moles. So we will get a experiment value of colligative property and a theoretical value of the colligative property that will not match because of the dissociation or association that is taking place in the solution. For the correction of this, we have our want-Hoff factor that is written as I, that is the ratio of normal molecular mass divided by the abnormal molecular mass. Now how we use this? For example, we have a colligative property as we discussed, osmotic pressure. Now osmotic pressure can be written as pi is equals to CRT. C is the concentration, R is the gas constant, and T is the temperature. Now this is the general term for the osmotic pressure. But if there is any dissociation or association that is occurring in a solution, we will write it as, to correct that, I CRT. Here I is the want-Hoff factor that we discussed, is the ratio of normal molecular mass or abnormal molecular mass. So this is how we use the want-Hoff factor. Now we have our fourth term as ideal solution. Now what is ideal solution and how can we define the ideal solution? We have one Raoult's law with us. Raoult's law, which describes us about the solution, about the properties of solution. According to this Raoult's law, the partial pressure of any component, for example, we have a component partial pressure that is PA, it is directly proportional to the mole fraction in the solution, that is written as chi A. This is the Raoult's law. If we write this equation, and it will be XA into P naught A. This P naught A is the constant and it is known as the vapor pressure of that component. Now this is the equation of the Raoult's law. Now those solutions which follows this equation are the ideal solution, and which deviates from this solution are the non-ideal type or the real solutions. Now one more thing, in case of ideal solution, if we write solute as A and solvent as B, we know that we have a solute-solute interaction, we have a solvent-solvent interaction, and we have a solute-solvent interaction inside a solution. If all these are equal, then we can say this is the case for the ideal solution. If they are unequal, then it is the part of the non-ideal solution. So this is the case for the ideal solution. Thank you so much.
क्लास 6 से 12 से लेके नीट IIT JEE मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।